We're going to have a conversation with you today about artificial intelligence, safety, and security. I'm Bill Pike from Pacific Northwest National Laboratory. With me are Jane Pinellas from the Johns Hopkins University Applied Physics Lab, who's an expert in AI test and evaluation, and two P&L colleagues, Nicole Nichols and Court Corley, both of whom are research leaders in AI safety and security. We had a session earlier today with a variety of speakers reflecting on this topic, and we thought we'd just sort of spend a little bit of time this afternoon summarizing some of that conversation, exploring the topic a little bit more, and also hearing from you with questions you have on the topic of AI safety and security. So the place to start things off maybe is just to have each of you reflect a little bit on what do we mean when we talk about AI safety, and what are some of the bigger concerns that you're each thinking about these days?
So I think that there's a lot of challenges around AI safety and security. One is education and awareness of what AI really means and the bias that's inherent in it. And so today there was a lot of discussion around kind of three components. One is the safety and security of the models themselves, as well as the interpretability, and how do we design models so that we can have trust in them and understand the types of results that are being used in them, and how do we design the test and evaluation frameworks to kind of provide that assurance. So in terms of which one is the most important, I'd say all of them. So I'll let others speak to what they think is most important.
Thank you. I think that's a great summary, first of all, so thank you very much for that. On the test and evaluation side, I guess we worry especially about adversarial AI. We worry about the quality of our data. We worry about the quality of our algorithms, and we worry in my job most about how we're going to test for security of all these things. And we have some ways to go about that already. We also have to worry about how these models will be used operationally, and whether or not our clients, who for us are for the most part warfighters, can actually trust the tools that they have, and to what extent and under which conditions.
So to kind of summarize what the research we're engaged in at the lab is beginning to think how you defend in a robust and resilient way the models that are out there that we know are susceptible to adversarial attack, or that could be susceptible to data poisoning, which are both ways of corrupting, so to say, what you would want an AI model to do. So what are the techniques, the mathematical methods, the machine learning methods that we need to develop in order to secure those models that would be used for computer vision or reinforcement learning or making action or something along those lines.
So when we talk about adversarial machine learning, can you talk a little bit more about what we mean when we talk about sort of adversarial inputs to AI or machine learning systems?
Right, so there's a variety of different things that we can mean by that. The classic examples tend to be around image analysis, where you can take the way that the models are trained and produce different types of inputs that then cause different types of misclassification. So one of the examples is someone puts in an image of a panda, they change some of the pixels in the image, and then it gets misclassified as a school bus. So there's fundamental ways where you can make these sorts of manipulations. Some of them are in the digital world, some of them are in the physical world. So there's also kind of a classic paper where someone 3D prints a turtle that, when kind of looked at it in different objects and orientations, it's misclassified as a rifle. And so there's a variety of different inputs, and kind of these are again in the image domain, but there has also been examples in text translation, trying to, when things are automatically translated from one language to another, insert different sorts of translations that bias towards an adversary's objective. So there's a variety of ways that people have been learning, and this is actually kind of found out through robustness testing, which I think is the other thing that's interesting to point out, is they're kind of inherent in most models, in part because of the data sets that we use to train them. If they don't fully span the types of things that we're looking at, this is why we think about what's happening in the real world. We train a data set, or train a model from a data set that only incorporates some sort of object of particular orientation. That model learns that bias. And so we need to understand the data sets that are being used and consider what is the full spectrum of scenarios where that's going to be evaluated.
So given all of those threats, how we validate and verify AI systems seems like it needs to evolve as well. So Jane, that's something that you've been working on for a long time. How do you think about how to validate and assess the quality or the efficacy of an AI system?
So we assess it in a few different dimensions. We usually start with a model assessment, where we look at essentially an academic set of metrics, and we just simply see how good the model is at what it's meant to be doing. Is it a good classifier? Is it a good translator? et cetera. We have to follow that up with what we call an integrated or a system test, where we see how the model will perform on an operationally realistic system. And we try to evaluate, are there latencies, are there any other issues that the system introduces into model performance. And then the third stage of evaluation usually is an operational stage. And it's at that point that we usually worry about the effectiveness of the model, the human factors associated with it, so the human-machine teaming and interaction. And that's also where we worry about what's called survivability, which is where this adversarial aspect comes in. Survivability is a little bit more general than that. We worry also about things like, in general, things like very basic things like model crashing and mean time between failures, and in general how it tends to perform, how long it can be down, what can bring it down. But then we also worry about things like data poisoning. We worry about things like misclassifications and things like that. And then finally, we're now getting into the realm of combining our traditional sort of mathematical science test and evaluation with ethical considerations as well. And we're starting to worry not just about whether the model does what it's supposed to do, but also making sure that it doesn't do things it's not supposed to be doing.
So another element of AI assurance has been what people refer to as explainability. So the extent to which an AI model can express perhaps the rationale behind a decision to a human operator, ranging from does the model work in a very predictable way, is it intelligible, or is the model entirely opaque or a black box? Can you kind of give us a sense of the current state of the art in AI interpretability and explainability?
So I think Dan, whenever he was talking earlier, talked about the psychological foundations for explainability and interpretability, and what each of those means. So interpretability really means how. So how does something work? Can you explain what are the things inside that make it work the way it does? And then explainability is really the why. So why is it working the way it does? So I have seen methods that answer the interpretability aspect of it. And so, for example, you have an image classifier, it classifies a tree, and then it highlights the branches. So a mask can say, or highlight parts of the branches and the trunks and the leaves, and say, this is why this is why the classifier decided to classify this as a tree. Well, that's an interpretable way of understanding the decision that was made by the model, because it says the leaves, the trunk, and the branches were part of the tree decision for this classifier, which is interpretable. But now when you begin to answer why and reason about, well, why exactly? Is it just because you were trained on a bunch of trees and so that's what you know a branch looks like? Or do you actually know it's a member of, some sort of flora, and that it's a member of some tree class or something like that? And so I think the answer is interpretability, we're likely getting there, but moving beyond that and explaining the why and the reasoning behind things and linking those kind of sequences of explanations together is the next set of research questions. And earlier we also talked about common sense, and I think a lot of those things come into play with common sense as well. Like with a tree, or like you learn as a kid, oh, that has roots, it has a trunk, it has branches, it has trees, and I know that's a tree because of that. I don't know it's a tree because it has, like my neural network says, like, these pixels say that that's a leaf. And so the next steps, I would imagine, in research are how do you do that reasoning about that to get to those answers for the models that we are developing.
The AAAS meeting brings scientists from a whole range of technical disciplines together, many of whom are starting to use or think about AI, machine learning in their domains. Are there things that scientists in other fields should be thinking about as they apply machine learning or AI into their fields, given all of these concerns around security, robustness, verifiability?
Well, I think there's a couple of things. First is the data itself, because all of these methods are generally driven by data. There's some that are kind of built from kind of explainable knowledge, but a lot of the advancements that we're finding recently are built from deep learning models, and so we have to think first about the data, because that's what's kind of driving the process from the start. So understanding what is in your data, what is the bias in your data, and how are you testing your data, and what are the metrics you're using to evaluate that. But also I think the other piece of that is putting in the simple sanity checks that you sometimes forget when you get really excited about the science, and you just kind of run ahead and you decide you've made a new discovery, because sometimes making sure that the data that you have or that the model that you are using is the one that you mean to have and is important for that robustness perspective.
think if anything, I'd like to make a plug here for interdisciplinary collaboration. We're seeing certainly in test and evaluation of AI where traditionally we're used to applying statistical methods or mathematical methods to it. Now that we're crossing over into very human factors heavy territory, we're looking at a lot of behavioral sciences as well, for instance. There's also room for UI UX type discussions and user interface type discussions, which are almost artistic in a way in nature, right? And then at the same time as we're crossing over into ethics, that brings in a whole another group of people into the mix. So I think that's where this is all going, and I think that's probably the most exciting part of it.
Okay. If there are things that folks in the audience are most interested in, feel free just to raise your hand. We can get you a microphone, and we'd love to hear your perspectives as well. Or just call it the question. I'm happy to repeat it.
I'm very interested in how subjective researcher choices actually change the outcome of a predictive artificial intelligence method. I did a little bit of research on my own for this, but it's very preliminary. I'm an undergrad. I'm wondering if this is an area other people have looked at and really seen, is it the data that's giving us this prediction, or is it just the way you happen to create your product?
So the question was about the impact of subjective choices that researchers make on the models of AI that they produce or the results that are created.
I can at least start addressing that question, I think. So usually what we'll see is a trade-off between a really good model fit and generalizability of that model. So it kind of depends on the goal. If your goal is to create a model that's really general, then you do want a wider variety of data, and then you're bound to get a model that doesn't fit any of those data especially well. Whereas if you're okay with what we usually call overfitting, if you're okay with a very, very tailored model, as long as you can summarize very clearly the exactly conditions under which it will perform well and under which it's going to start breaking down, then I think that's also okay depending on the purpose. So I think the issue isn't so much with should you or shouldn't you. The issue is, what's the purpose of the model and whether some of these trade-offs, where you want to go in the space of those trade-offs, if that makes sense. So you have to be very clear about what data you use to train the model, and that's within sample prediction, that's kind of where you're probably going to be. And anything out of sample, you start entering very dangerous territory. Sometimes that's what you need to do, but then you have to quantify what the risks are that you're taking in that space.
I think another aspect of that is the scenario where you're working in. If you're working in a theoretical space, trying to prove a fundamental theorem, or if you're working in the real world. Because I think that there's in the theoretical space, you tend to try and take away as many other varying factors as possible, but then as soon as you get to the real world, then you have the unexpected things. So like the backup cameras on a car, if there's icicles on the back of the car, then it starts to think that you're going to hit something even though there's nothing behind you. And so when you think about these design choices, again, you need to think about which application space you're trying to make an advancement.
I think based on the conversation we had earlier today and in other sessions in the meeting, there certainly is a huge role for social science researchers in this space, understanding human AI teams, understanding bias in data set collection and how the models are created. So certainly another opportunity for more interdisciplinary research. As you sort of think ahead maybe to the AAAS meeting next year, are there sort of predictions or things that you expect you think we'll see the AI assurance field move toward in the coming year?
I would hope to see that there's some more standard evaluation metrics and kind of a thought about which data sets people are using to evaluate things, because I think it comes back to this question of, is the data set reflective of, or fully reflective of the challenges you're trying to solve, and what are those metrics? Because I find that there's a lot of ways to look at those problems, and the more we can kind of come together as a community to decide ways that are most effective, and kind of then that allows us to compare across these different methods which ones are being effective in these challenges, because the robustness of the models is a growing challenge, and so being able to look at that effectively and comprehensively, I think, is going to be important.
So challenge accepted. And we'll definitely, it's something that we're working very hard on, but it is a very new field, right? And so with it come a lot of challenges, specifically at least in the operational test space, we know how to measure the performance of some of these models in these very pure academic, ivory tower type ways. And when we try to figure out what are the operational implications of the models, that's really the difficult part right now. But especially where we talk about robustness, for instance, that's not something people know they have to worry about it, but it's not necessarily a way we figured out how to measure models by. I would also say it would be very interesting to start measuring, or start getting at what level of performance is actually acceptable. What's the requirement of AI models? And that's something that we really have trouble, I think, understanding as humans. We tend to think of human performance as this very level and very accurate. And probably neither of those things are true. My favorite example that I like to give to my colleagues is, you know, a machine didn't get into like a fight with its spouse last night and lost a night of sleep, and all of a sudden today is having a terrible day, messing everything up, right? A machine performance is considerably more robust in some ways than human performance, and we don't tend to think about things like that. We tend to very much idealize human performance. So I think it would be very interesting to get at where is human performance and what are the expectations that we have of a machine versus a human. Another good example of that is the minimum qualifications of your Uber driver, right? And if you think about how, if you called a car and an autonomous car arrived and all you knew about it is that it hadn't had an accident in 3 years and it's driven 60,000 miles, would you get in? And the answer for most people is no. But that is the only requirement we have of our Uber drivers, right? So again, we have vastly different expectations of machines than we do of humans, and it would be really interesting to start putting to basically start quantifying what is the requirement, how good do machines really need to be in order to start taking on some of that human workload.
Ditto.
So we have a couple minutes left. If there are other things that folks in the audience are curious about in AI safety, we're happy to hear them. So the question was about the state of autonomous vehicles. I don't know that anyone in the room is an expert in autonomous vehicles and wants to summarize on that topic. But if you've got some research you want to share, results to share, go for it.
This is personal opinion and not the opinion of anything else. I follow it with curiosity. I think that one of the challenges is probably legal challenges in terms of having authority to be on the roads. There certainly are many scenarios where autonomous cars are certainly active in collecting data and are seen on the roads. And I think some other countries have different regulations around how those autonomous cars are in deployment, and I think in some countries they actually are. But in terms of broad adoption, I think that there's just still a lot of human uncertainty around what that reliance and robustness is of them, which is why we're having this kind of precursor discussion around resilience and reliability in these autonomous systems.
Maybe one more question in the back. So are there things that you think the general public should be thinking about when we talk about AI and machine learning, particularly from a safety and security perspective, since all of us end up using or are on the receiving end of machine learning algorithms? Are there things that you think should be on people's minds as they interact with online systems or interact with each other through AI and machine learning?
So I would say it's almost a simple question of awareness. You know, ask the question, how do I know that this was designed with safety and security in mind? And what are those things that you're going to show me that you did during the development of this car, this product, or otherwise, to say that you intentionally applied operational test and evaluation and other techniques for making sure that the AI in the system and the complex system is going to work the way you think it's going to work. And so for the public, you know, I think that's what we can ask of our product makers, is say, how do I know that this is developed with safety and security in mind?
I think the other piece of it, which is a different can of worms, is data privacy. which is a fundamental part of this as well, and something that is our individual choices of how we use our data and what data we have publicly accessible. So just kind of thinking to yourself which, at least asking the question of do you have a data policy for this data, and being aware of that in addition to the pieces around how these models are being built and used.
It was the silence bracelet. The silence bracelet. Yeah.
So the question was about wearable devices or other ways that people might obscure their ability to be recognized by facial recognition systems or otherwise. Right.
As somebody who works closely with the Department of Defense and Intelligence community, that is not a concern of mine. There are quite a few legal implications about surveilling United States citizens, so really not worried about it anytime soon.
Just from a commercial perspective, I've always been forward-leaning, so just my personal philosophy is, I go out there, I use the tools, I acknowledge that they're free, and I acknowledge that the reason why they're free is because my data is being used. So I did resist using Alexa in my home for years, and then finally it just was like, oh, it's $40, oh, it's $30, oh, okay, well, might as well now. So for me, internally, for good or for bad, I felt like I had this philosophical cost-benefit. And in my home, if I want to have a conversation, I'll turn it off. It's one of those things. A lot of people are probably making that same personal decision of, do I want to have this device? Now, what I think should probably happen more is an awareness. Like, know that when is the device recording? When is it sending that recording back to the cloud? And I think that's the part that we don't know right now, and is the uncomfortable part. Like, I would have a lot more trust maybe in my device if I knew it wouldn't send it back. But that's not my area of research. That's just me as a commercial consumer and my personal thoughts and reading the headlines of the articles that you said.
Okay. Well, we're about out of time, so thank you all for spending a little bit of time with us this afternoon, and we'll hang around for a couple more minutes if there are any other questions. Thanks.